Ngā mihi o te ata. Good morning. And we have arrived at our last topic for Section A. So we've come a long way very quickly. And the focus this time is on what we call equilibrium of the firm. And in economics, when we use the word equilibrium, in the most simple or simplified way of understanding it, it means the best place to be. And most models in economics actually tend towards equilibrium. That is the assumption. Anyway, when is a firm happiest? Well, what is a firm trying to achieve? What is it trying to do? And in this course, we assume that all firms want to maximize profit. And so what we're going to do is look at our graphical models. We've already looked at half this model when we did the unit on costs. And we're going to put in our revenue curves, and we're going to look at how to calculate profit and then find out the place, the output, the firm will maximize profit. So as we can see below, the unit examines how profit is defined and calculated. Secondly, we'll do the graphical models for individual firms operating in both perfect competition and imperfect competition, which we looked at in the previous topic to introduce this one. So let's go. Now, the calculation of profit firstly is based on the assumption that the aim of the firm is to get as much profit as possible, to maximize it. It does this by selling goods and services. In other words, it gets revenue, which is of course price times quantity, and then it subtracts the total costs of supplying that good. And you can see in the rectangles below that in this example, total cost is less than total revenue, and so there would be profit that is positive, and as you'll find out, it's called super normal profit because it's above zero. Remember, total cost is calculated by multiplying average cost times quantity, and total revenue is price times quantity. So profit is categorized into three types: one where it's above zero, one where it equals zero, one where it's below zero. And so the first is what we call normal profit. We've already encountered this term. Normal profit is defined as just enough to keep the firm producing in the long run, in other words, to stay in the industry, or sufficient to cover all economic costs in the long run. This is called, as we remember when we did break-even point, total revenue equals total cost. Supernormal profit is more than enough to keep the firm producing in the long run. In other words, profit is above zero. It's found where total revenue is greater than total cost. On the graphs, you'll see AC is below AR at the profit maximizing output. And subnormal profit, sub of course meaning below, so not enough to keep the firm producing the good in the long run. They would leave the industry. Oh. So total cost is greater than total revenue. On the graphs, AC is above AR or price at the profit maximizing output. So once again, normal profit economic profit equals 0, and remember that's perfectly okay because the revenue earned covers all the economic costs. That includes the opportunity costs of being in that business or producing that good. When it's above normal, profit is positive, and below normal, subnormal, it's negative. So here's a simple pictorial graph, I suppose, where you can identify the outputs where the firm is making supernormal profit, subnormal profit, normal profit, and what outputs is it maximizing profit. So supernormal profit, of course, is where the total revenue is above the total cost. So anywhere in that area there, the firm is making supernormal profit. Subnormal, therefore, is from O to A and after C. Why? Because total cost is above total revenue at those outputs. Normal profit at A and C, because total revenue equals total cost. And of course, in this diagram, where total revenue is at that point there and total cost is at that point there, they're at the greatest distance apart, so we could assume they're maximizing profit. Now let's have a look at the firm's revenue curves, and remember total revenue is price times quantity. Now remember we have two types of competition, two types of markets, perfect and imperfect. In imperfect competition, if you calculate total revenue, as output increases, total revenue will increase at a constant rate, and that is because the price doesn't change. Remember, in perfect competition, this individual seller is a price taker. So the market sets the price for each individual seller. And of course, this is the total revenue curve of one seller. Therefore, as you will remember, that the marginal value measures the rate of change in the total. So if we draw a marginal revenue curve, it must be perfectly elastic. In other words, a horizontal demand curve. So let's look at average revenue now. Remember that we calculate average revenue by taking the total revenue and dividing it by quantity. Remember, we're in perfect competition, so the seller is a price taker, the price is set by the market, the individual seller takes the price. So total revenue, P times Q, if he can produce more, his total revenue will increase by the change in quantity. Now, average revenue always equals the price. If we look at our equation, we know total revenue is price times quantity, and the average value is simply divided by quantity. So, we can see just mathematically that the average revenue always equals the price. And this is important when we look at the graphs that are coming up. Now remember the bottom diagram, we've got two graphs, and we've got the market and we've got the individual seller in the market. Remember, he is one of many sellers in the market. He's a price taker, so the market sets the price. He takes the price. Now, if demand increases in the market, then of course he will be very pleased, the individual seller, because he'll get a higher price and therefore will earn more revenue. Now we're going to look at the very heart of the graph. It's where does a firm reach equilibrium? Well, we know it's aiming to maximize profit because that's where it will be in equilibrium. And a firm will do this when it chooses an output where the marginal revenue equals the marginal cost. In other words, a firm will maximize profit at the output where the extra revenue earned from selling another unit of the good is just equal to the extra cost of producing it. So the golden rule, if you like, is MR must equal MC at the chosen output. If you choose any other output, profits will not be maximized. So when you look at the graphical models, every time you have to find the quantity, the output, where marginal revenue equals marginal cost. Any other output will be incorrect. And so much of your analysis will be incorrect if you choose the wrong output. So it's vital that when you're analyzing these graphs that you find that point and then identify the output. So let's go and examine it more closely. So where is the best output for the firm to produce that? Where it maximizes profit. So where's that? Where marginal revenue equals marginal cost. So as you can see, this is true for both perfect and imperfect competition. The quantity is always the same point where marginal revenue equals marginal cost, the firm will get the most profit. So in the first diagram, and this is a fairly typical multiple choice question, if marginal revenue is greater than marginal cost, what should the firm do? So we take a point, and we can see there, any point below from 0 to Q, you can see marginal revenue is above marginal cost. So what should the firm do? Well, the answer is it should increase output. At any point quantity past Q, marginal cost is above marginal revenue. So what should the firm do? Decrease output. Exactly the same applies for an imperfect competitor. They maximize profit where MA equals MC. So they choose that quantity there, Q. If marginal revenue is above marginal cost, same idea, increase output. But to increase output requires a decrease in price, so quantity demanded will increase. So unlike the perfect competitor who can't control a price, he can't change it, imperfect competition, sellers have either weak or strong control over price, or in the case of monopoly, they are price makers, so they simply will decrease their price in order to increase sales. And of course, if marginal cost is above marginal revenue, they will decrease output or increase price. So now we're looking at our first example, the easiest one to look at because we're going to be looking at normal profit. So at the profit maximizing quantity, we're going to see that total revenue equals total cost. Now remember, we're always in the short run when we draw these diagrams. In the short run, at least one input is fixed. So the law of diminishing returns applies. And that in the short run, firms of course can make below normal, subnormal profit. Now let's have a look here at why the profit maximizing point is at this point here. Why? Because the extra revenue earned from selling the unit just equals the extra cost. So if the firm chooses this output, it will maximize profit. And in this case, economic profit will be zero, but it can't be any larger than that. So let's have a look. P times Q, or AR times Q, of course, is total revenue. Now you'll see at that point there, at our lowest point of the average cost curve, that is the value of average cost. So average revenue equals average cost. So therefore, average cost times quantity, total cost, is exactly the same. So total revenue equals total cost, and economic profit is zero. Now we know this firm is operating in perfect competition when we look at the horizontal demand curve. Perfectly elastic, which indicates the seller is a price taker. The second way of recognizing that this is perfect competition is that the value of average revenue is the same as marginal revenue. Unlike in perfect competition, marginal revenue is below average revenue at every output. So use the graph to explain why the seller is operating in perfect competition. The seller's in perfect competition because the demand curve is perfectly elastic, which indicates the firm is a price taker and therefore has no control over price. And therefore, average revenue is equal to marginal revenue. Right, our next example, if you look closely, you can see that the average total cost is actually below the average revenue. And so immediately you can know more or less that there's going to be supernormal profit because average revenue is above average total cost. Not at every output, but at the relevant outputs. So let's have a look and see. So the firm will maximize profit if it chooses this output here, because that's where marginal revenue equals marginal cost. Price, remember, equals average revenue. So P times Q, total revenue. Now where is average cost at this output? Well, there's your quantity output. Average cost is here, so the point is there. Not down here. Any students will choose that point. It's not the lowest point of the average cost curve. It is where the quantity intersects that part of the average cost curve. So make sure you're very careful when you draw or indicate the amount of profit or the total cost that is clearly seen. See, once again, at that point, the average cost at that quantity. So total cost, AC times Q. And the difference, you can see average revenue is above average cost. So total revenue is greater than total cost. So the difference, supernormal profit. So as a good review of this graph, now go through and use the labels to identify total revenue, total cost, and of course the calculation of supernormal profit. So I'll leave that to you. Now our third example, or type of profit, we can see is going to be subnormal profit. How do we know? But immediately we can just see by looking at the position of the average total cost curve. At every output, it is above average revenue. But your job is to be able to identify the profit maximizing output and how much profit is actually made at that output. So let's do it. MI because MC is there at that point. So draw a quantity line straight up until you reach the average total cost curve. Why? Because you will see that average total cost is going to be above the price or average revenue. So that's your average cost. You can see average revenue below. Total cost, 20 times 100. Total revenue, 16 times 100, which is greater, obviously, total cost. Average cost is above average revenue. So you have subnormal profit. Right, take the numbers, do the calculations, and see if you're correct. Ask me in the teaching session if you're not sure. So in this example, you've got the kiwi fruit market, and a few years ago, before kiwi fruit, which now is rebranded as Zespri, became very popular, it was an industry where individual sellers were making subnormal profit. But as kiwi scientists worked on improving the quality of the fruit, making it more juicy, sweeter, and also developing a thinner skin so that it was easier to access and eat, these changes, plus a strong advertising campaign, resulted in a massive increase in demand for kiwi fruit around the world. So if we say the kiwi fruit world market is on the left, and you've got the individual seller of kiwi fruit cost and revenue curves on the right. Now, if at the existing world price, you can see at the profit maximizing quantity, average cost is above the price, so this seller is making subnormal profit. But things didn't stay that way. Gradually, there was, due to the improvements I mentioned and the advertising, a large increase in demand for kiwi fruit. Of course, the price rose, and kiwi fruit sellers in New Zealand were very, very happy because they ended up making either normal profit and in many cases supernormal profit over time. And so we can see again, and this is an illustration of how changes in the market will affect individual sellers' profitability. This exercise is, you've got at the market price, you've got three different sellers, individuals, and you're asked to show the first firm making supernormal profit, the second one subnormal profit, and the last one making normal profit. So I'll leave you to draw the average cost curves in the correct position, label the profit maximizing quantity, the price, and the average cost of producing, and shade the amount of super, normal, subnormal, or normal profit. If you want more detail about how these graphs are constructed, then please go to the video links by Stephen King, and especially if you're mathematically minded, he will give you, also show you how the functions are actually used to develop the curves, if you like. So please, if you want to look at this to deepen your understanding of the models, do not hesitate.